Perfect. Thank you very much for the introduction. What I'm going to present right now is a collaboration between myself, Miguel Nacenta, and Hinrichs, all from the University of St. Andrews. So the takeaway message of this talk is that considering agency and granularity is important when designing visualization tools. And hopefully by the end of the talk, you will understand why and what we mean with this. So let me explain what motivates our work. In previous research that we presented last year at SIGCHI, we investigated how different visualization tools influence the design process of non-experts. And we compared the use of two radically different tools, namely Tableau and our own tool, Evolver. And this is how these tools work. So in Tableau, you drag and drop data attributes to specific parts of the interface. And then in response to your interactions, the tool produces visualizations whose marks you can customize using also drag and drop interaction. Now, in this case, for example, we are dragging attributes to modify the color of the marks or label them, etc. Tableau also includes a built-in recommendation system called the Show Me pane that allows you to select predefined visualization designs using single interaction steps. Evolver also based the visualization constructions on drag and drop interaction. But here the construction takes place within a canvas in which you bring visual marks, you access the properties, and you connect individual values from the dataset to those properties. Now, because here we are manipulating individual values of the dataset, we need to repeat this process for every data point we want to represent. So there's a lot of repetitive interaction steps. We investigated Tableau and Evolver as representatives of continuum between top-down and bottom-up approaches to visualization authoring. And this is what we mean with this. Tools that implement a top-down approach, such as Tableau, operate at the level of attributes. They require the specification of the visual mappings at the beginning of the process, and only then it is possible to customize other aspects of the visualization. On the other hand, tools that implement a bottom-up approach, such as Evolver, allows us to manipulate individual values, and because of that, the visualization is incrementally generated, and it results after many small-scale decisions and manipulation. Now, in our investigations, we were able to identify benefits and limitations of these approaches. So in the top-down approach, often we have a lot of automation, and because of that, it is easily and very quickly to explore alternative visualization designs. The problem with that is that because the tool includes a lot of default behaviors, we also have cases in which the tool takes the design lead, and that also imposes very little critical reflection on the designer, on the non-expert designer side. On the other hand, tools such as Evolver, everything is done by the designer, which results in a transparent process. But the problem with this is that it requires a lot of repetitive interaction, so the process of visualizing data becomes tedious and is not scalable, meaning that if the number of data elements grow, the process becomes more and more time-consuming, and it requires a lot of effort. So the research question that we address in this paper is how can we design bottom-up visualization tools that are also scalable? And with that, what we mean is how can we bring together the benefits of both approaches, top-down and bottom-up? So in order to answer this question, we followed a mixed methodology. First of all, we conducted an in-house design exercise in which we revised the design of Evolver in order to propose solutions to the scalability problem. Second, in order to consider other solutions that we might have overlooked, we conducted a series of design workshops with people from different backgrounds and levels of expertise who, after interacting with Tableau and Evolver, proposed a sketch and presented solutions to the problem of scalability, and we recorded this data. We then combined the result of both exercise efforts and conducted a thematic analysis using an open coding approach that was done in several iterations. And this is what we found. So what you see on the screen right now is a set of some of the designs that participants generated in the workshops. And what I'm going to explain now has to do with how they propose to specify visual mappings. And here, we were able to identify 17 unique ideas, which can be classified in 8 different types, and these 8 types compose 3 different families of solutions. And those families are visualization by example, collective proxy objects, and automated principal design. So what I'm going to do now is that I will give you an example of each one of these family, and then I will talk about the general concept behind each. This is an instance of visualization by example as proposed by participant 6. So here the visualization process begins with this circular mark, whose label is controlled by one value from the name attribute, the size of the circle is controlled by one value of the salary attribute, and then one value of the department is converted into a color to paint the mark. Now, after you have specified these mappings using this single instance, we can hit this plus button that allows you to select a new data record. In this case, we click on the row that has the information for Rachel. And what the system does with that is that it creates a visual representation for Rachel using the same mappings that we specified for Charles. So in this category of solutions, the visual mappings are specified manually using a single example mark and individual values. And then what the tool does for us is it replicates the mapping using other portions of the data. And the underlying strategy of the family is something that we call automated iteration that addresses the repetitive interaction steps that the user would otherwise have to carry out in the process. And the idea is that here is the tool the one responsible to repeat my decisions as a designer. The second family is collective proxy objects, and this is an example of that. So here the visualization process begins with this rectangular element, which is not a visual mark. Instead, it has several places where we can connect data attributes. For example, the department attribute here is connected to the label property of the widget. And after configuring some more mappings, we can generate the resulting visualization, which in this case is a bar chart because the original element was a rectangle. Another proxy object would be Tableau marks card, in which we specify the visual mappings in a separate area of the interface, and then the visualization appears in a dedicated area. So in collective proxy objects, we configure the mappings manually, but this time we use data attributes and through a proxy widget. And all the changes that we are producing in the proxy widget are reflected in the elements of the visualization. And here the underlying strategy is abstraction, by which a single element represents many other elements, and the individual components are not directly manipulatable or accessible to the designer. Finally, the third family is called automated principal design, and this is an example proposed by participant 3. So here the visualization begins with this widget that has access to which we can connect attributes. And in this particular example, we are connecting the salary to the vertical axis and the name to the horizontal one, and nothing else is specified. So here the tool has to take a few decisions on what to produce with this input, and what it does is that it generates a bar chart because it says with a quantitative and a categorical attribute, I can represent this data this way. Another example of automated principal design is Tableau Show Me Pane that suggests several recommendations according to the data attributes involved. So in this family, the mappings are decided by the tool. And the tool has to implement a top-down approach to visualization in order to come up with a visualization. And the underlying strategy of solutions in this family is something that we call automated choices, by which explicit decisions of the designer are minimized and are taken by the tool. So with this part of our analysis, we were able to identify 3 different families of design solutions to solve the problem of scalability in bottom-up visualization tools. And each one of these families implements a specific underlying strategy. Then we were considering what are the dimensions that can tell these families apart. And that brings us to the design space that we present in paper and that we define in terms of agency and granularity. So agency has to do with who carries out the visualization process, whether the tool or the visualization designer. And it has to do with the many decisions that we have to take when visualizing data. For example, who selects the visualization type, or what kind of data transformations we are going to be applying, or who decides the visual mappings. On the other hand, the concept of granularity has to do with what designers have access to. And at the level of data, for example, we can start the visualization process manipulating individual values, as in Evolver, or we can construct subsets or manipulate entire attributes, or we can go to higher levels, for example, manipulating entire tables or even the entire data set. At the level of visual representations, and this sort of compose a continuum of different levels of granularity. At the level of visual representations, we can also have several granularity levels. As in Evolver, we can begin to manipulate individual marks, or as in Tableau, we can manipulate the visualization as a whole, or even go higher to small multiples or even dashboards. So these two dimensions, agency and granularity, compose a design space. And in the bottom left corner of this design space, we find pure bottom-up visualization tools, such as Evolver. Now, if we apply here some automatic iteration to these tools, that is going to shift the agency balance toward the tool side, because now the tool will be responsible for applying the decisions of the designer in to a larger scale. If we add here abstraction, we are not going to go higher in the granularity axis, but we are going to lose a lot of agency as well, because now the tool will be responsible for even more tasks. And finally, if we here add automated choices, we're going to even place more agency on the tool side, and an example of this could be Voyager, for example. So in our paper, we divided this design space in 4 different quadrants. You can read the descriptions of them. And we also located several well-known visualization tools and discuss how they fit in this design space. And just to give you an example of an extreme case, in this point, we can find tools such as Watson Analytics, which can generate visualizations from an entire database or data set without almost any human intervention. So what are the implications of our work? First of all, we provide examples of solutions on how to scale bottom-up visualization tools, and we uncovered 3 different families and strategies to solve the problem. Our design space also helps to characterize the consequences that applying these strategies would have in bottom-up tools, and we hope that tool designers consider them in order to design better visualization tools. We also believe that our design space provides a critical lens in order to understand a little bit the current visualization tools landscape. Although we did not conduct a comprehensive survey of visualization tools, most of the ones we looked at are located in the upper part of the granularity axis and towards the right side in the agency one. This suggests that a lot of effort from the visualization community has gone into created tools that take a lot of responsibility for the design decisions that we have to take when visualizing data. And this is fantastic, because if we are experts, we are going to be using these tools for teaching, research, and design. But we believe that there is a lot of space for exploration, in particular when we have to support visualization for non-experts. So just to recap, we believe that it's important to consider agency and granularity when designing visualization tools, and we invite you to do so. And with that, I thank you all very much.
Is there a question?
Hello, thank you for your great presentation. I'm Mikko Illi from Aalto University. Mm-hmm. And interestingly, we are also looking at visual granularity, where we look at recipients and the visual granularity in visualizations. So this is super relevant to what I'm doing. Would you, in sufficient way, answer sort of that where does the notion of data granularity originate from?
Okay, so in our design, in our analysis, it was a consequence of what we observed from the data we collected. So essentially, when participants were presenting their solutions, and even in our own solutions, the concept of agency and data granularity was present, because they would say, I'm going to manipulate individual values, or I'm going to create groups of data, or I'm going to work with the entire data set and things like that. So the concept was something that sort of emerged from the analysis that we conducted on the solutions that we collected, essentially.
Okay, thank you very much. I talk to you after this.
Thank you very much.
Hi there.
Hi.
Great talk. I'm
Thanks.
Jacob Ritchie from U of T. I was wondering if you could talk a bit about how the other three presentations in this session would fit into the design space.
Oh, that is a fantastic question. Thank you. So I believe that we saw a lot of automatic iteration in Data Illustrator and in both in Infonize and Data Inc. Because surprisingly, these are concepts that are underlying to any tool that you want to scale to use larger data sets. Otherwise, you end up with tools that you can express a lot, but they don't scale with a number of data elements. Another concept that was very common in the previous tools was the concept of abstraction, by which you use a single element in order to modify all the other elements of the interface, and you specify visual mappings using this proxy. I believe that in Data Illustrator, you do that through, it was a collection or something like that. So you modify one particular collection, and then these changes are reflected in the other elements that compose the visualization. It was very nice to see these concepts already applied in the tools as well. Yeah, thank you.
Thank you.
Hi there, Danielle Fisher, Microsoft Research. I really enjoyed this presentation. And
Thank you, Daniel.
And this coordinate space is super useful for me to think about, although I'm trying to argue to myself why I want anything to be in that bottom left quadrant. Specifically, when I think about Excel, for example, the most common bug that we run into is people who fail to copy a formula all the way down, and that feels like that's what high granularity is inviting.
Yes. So normally when we design visualization tools, and tools in general, I would say from the interaction community, we try to maximize the performance, meaning and efficiency, meaning that we want things to happen quickly, and the user doesn't have to spend a lot of time with the tool. However, we have empirical evidence from previous studies that show that repetition and effort actually has a benefit, especially for non-experts. So I was talking about underexplored areas of research that would benefit the non-expert community in order to better understand and appreciate the value of visualization design. Because otherwise what we are doing is just designing black boxes, things that do the things for them, but they are not critically reflecting on what's going on what the tools are doing on their behalf. And that's our main argument in that. Thank you.
Thank you very much. Thank you for the question. Thanks for the answers. And let's thank all our speakers. It was a wonderful session.